Hello everyone, welcome to the lobby waiting area for the Cisco CCNAv3 short course. We'll be starting very shortly. Matt's on hand and we've got a bunch of support staff for this first one. Hope you're all excited. Let the chat flow. Already up to 550 attendees, so it's going to be a big one tonight.
Hi everyone, James here. Just a note to anyone who wants to chat to each other rather than just to all panelists. There's a drop-down option in your chat box that says either to all panelists or to all panelists and attendees. So if you just select all panelists and attendees, it'll go to everyone. We might end up with a very active and chat box is quite difficult to even follow, but that's why it's fortunate that we've got the Q&A section just for content-related questions.
Yeah, that's a good point. Someone's typed in a raised hand will actually perhaps help if you have a question. Yes, Josh, it will be recorded and available for download later. I'll jump into all of that very shortly as we begin the webinar.
Mike has just said there's some serious background hum on one of the mics of the panelists. Do we just want to try to check which that is?
I'll turn mine off now. And I'm back on.
Hard to tell. I think it kept going a little bit after you turned yours off. I'll mute mine.
All right. Ready to go, Matt?
Yes, anytime.
Oh, beauty. I'll shut off my horrible webcam and we'll start getting into it.
All right.
Just one sec. Sorry, Matt. I'll get into the launching spiel. Hello, everyone, and welcome to Cisco CCNAv3, a short course presented by IT Masters on behalf of Charles Sturt University and the Information Technology Professionals Association, or ITPA. My name is Guy Coward, and I'll be your MC tonight, and for the duration of this course, your mentor is Matt Constable, who you'll be hearing from shortly. Before we begin, just some housekeeping. All webinars for this course will be held at 8 o'clock Australian Eastern Standard Time. Check your local times, with recordings made for those of you who cannot attend on a given night. Despite this, if you can make it, we really do hope you attend the live webinars and help contribute to a collaborative learning environment. We think it's a really great forum for creating that. On that contribution, as veterans of our other short courses would have noticed, we are not using our usual platform to deliver lectures. This is the first free online short course IT Masters has presented using Zoom, and we're looking forward to seeing how it works with several hundred students. For tonight, we ask that you direct all course content related questions to the Q&A section and send all administration type questions to the support team in the chat function. You can chat with panelists only or to all of your fellow students, as James has said. And given the enormous cohort, I may periodically need to freeze questions just to handle the load if it's getting a bit unmanageable. So sorry in advance for that, and I'll let people know if that is about to happen. For those of you who have never taken part in a short course with us, IT Masters is a training organisation that exists as a partner to CSU, who we work with to create and deliver a number of their Masters courses. We also market these courses on their behalf and think and hope that the best way to do that is to give some of them away for free. If we do a good enough job, then students will be encouraged to enrol in the full Masters if it suits them. We're also proud partners of ITPA, who are helping facilitate this course. The president of ITPA, Robert Hudson, is enrolled in this course and attending, and will briefly outline what ITPA is and why they do what they do at the end of the lecture tonight. So hang around for that one. With all that said, this course does stand alone in its own right and is its own reward, I think. We want you to learn some useful information, have some fun, and hopefully make connections with your fellow students. I just want to thank James, Diane, and Nick, who are on hand in administrative and technical support roles from IT Masters, and they're also responsible for the learn.itmasters.edu.au website, which is where you'll find all of the materials needed for this course: readings, discussion forums, and quizzes. If you have any questions tonight or later on about the course, please feel free to contact us using the details on that page. Just a note on the forums as well, we're also trying a new system of directing discussion this course compared to previous short courses, whereby we designate threads for discussion points in the forum, hopefully leaving space for student-led discussions on other threads. We really like trying new things in our short courses and seeing if we can improve our practices generally, and would really welcome feedback via our email on the course page. If you do have any questions about the full Masters courses, we have a representative of CSU joining us next week to hopefully answer those questions, so maybe don't ask them this week. And one last thing before I hand over to Matt, we have a poll up on the course page about students' levels of experiences with Cisco, but we thought we'd ask in a lecture as well. I'll just launch the poll now. And as it doesn't get shown in the recording, the question is, how much hands-on experience with Cisco have you had? 0 to 1 year, 1 to 2 years, 2 to 3 years, or 3+ years. And early indications are that it's very similar to the responses, despite the increased sample as compared to the Moodle page. About 63% 0 to 1 year, 12% 1 to 2 years, 6% 2 to 3 years, and 19% 3+ years. And that's a sample of about 650 students. I'll end that now, Matt, and share it on the screen. And I suppose now is a good time to introduce Matt. As usual, it's far too much out of me. So please welcome your mentor for the next 6 weeks, Matt Constable.
Lovely. Thanks very much, Guy. And welcome everyone to the first week of our Cisco CCNA version 3 short course. So some of you may have been involved with our version 1 course, which we ran a couple of years ago, 2-3 years ago maybe. And that was obviously very successful. So this one here is really an update for the new CCNA version 3 exam. So that's why it's the V3. It approaches the, looks at the requirements for the version 3 exam. So tonight, part of this short course is based on one of the subjects that we run at IT Masters, so ITE 526 Practical Internetworking, that is part of the Masters of Network and Systems Admin and the Masters of Management in IT. So if you go through this CCNA course with us, a lot of this information that we cover in the next 5 weeks is similar to what we do in that particular subject. So it's a nice little segue, nice little lead into that. So as Guy said, my name is Matt Constable. There's some details about me which I won't go into too much detail about, but suffice to say I've been in the IT industry for quite some time and worked across a number of different technology streams and in a number of different areas on both the customer and integrator side of the fence. I certainly don't have all the answers. Various people out there, depending on your experience, will have lots of different things that you can bring to the table, and I fully encourage you to use that as much as you can, particularly in the forums. Forums are a really good tool. A lot of recent research coming out of some of the best universities in the world show that if you engage in forum activities regularly, you get much more out of your learning than you will if you just sit there and sift through them and read. So certainly become active, talk to each other, build up that network, and help to share the knowledge around, because everyone, I'm sure, has got something that they can share with us. As Guy said, our class times Wednesday 8 o'clock. So that's in the +10 from UTC time zone. That's Australian Eastern Standard Time. And we upload, obviously, these recordings up onto the Moodle website and on YouTube, usually within 24 hours of the cessation of the actual class. So always be there. If you have any troubles accessing that, by all means, send us an email or post onto the Moodle site, and we'll be able to help you out with that. To contact me, gone too fast. To contact me, easiest way is via the course forums. And the reason I say that is then everyone will be able to share in the answers that I give to any questions that you may have regarding the course content. Now, there'll be a number of us from IT Masters that will be looking at those forums and answering different types of questions. I'll mainly be looking at the content related questions. So if you've got any questions about what we talk about in the webinars, or to do with the packet tracer labs, or any of the materials, please feel free to post the forums and ask me a question. That's fine. We're here to help. So tonight we're going to look at a Cisco certification brief overview. So the certifications mainly only up until the CCNA level, because that's basically what we're focusing on. But we'll also have a quick look at CCNP and the other more advanced certifications, just so you know how they articulate together. The content that we're going to cover over the next 5 weeks is covering the most recent version of the CCNA exams, which are 200.125, which is the CCNA accelerated exam, and I'll explain what that is very shortly. Or the other two exams are 100.105 and 200.105, which correspond to ICND 1 and ICND 2. And again, I'll explain what that means as we go along. And also have a look at discussion about some online labs that you can use to help with your Cisco certification process if you haven't got access to the real equipment. And some brief study tips which are useful for you to keep in mind as you're going through not only this particular course, but other courses that you may engage with, or any other learning activities that you engage in as your career progresses. So in terms of the certification overview, CCNA is a second level Cisco certification. So there are 2 other certifications that sit below that. That's the CCT and the CCENT. And they are single exam certifications, very, very entry level. So although CCNA is a second level certification, it is still the fundamental grassroots certification that Cisco offer, and probably the first one that I would advise most people to go for. There are 2 ways to get your CCNA. The first way, and if we just flick to the certification website, probably the easiest way to have a look at that. So that's this one here. So to get a CCNA, the 2 ways you can do it. So if we look at just routing and switching CCNA, and I'll talk briefly about the other flavors as well shortly, but at this stage I just want to focus on the RNS, route and switch. So the 2 ways to get it are via the accelerated exam, which I mentioned just before. That's exam number 200.125. So it's this exam here. Or you can split it into 2 other exams, so ICND 1 and ICND 2. Now, the course content we talk about over the next 5 weeks will help you some way down the track to preparing for all 3 of those exams. The difference is the CCNA accelerated exam, so this one here, tests you on all topics at the same time, all topics on the CCNA topic list at the same time, whereas ICND 1 and 2 break them down into 2 halves effectively. So if you're not confident that you can cover everything in the one exam, then you can split into 2 exams and take it that way. My advice is to, my preference was and still is, and my advice I give to people generally is to take the accelerated path. It's only a single exam, it's less expensive. You also get a lot less questions because they're spread across a broader area of topics, but you get less questions on each topic area. So in my opinion, it's a little easier to go that way rather than go down the 2 exam path. But if you're feeling particularly nervous about it, or there's a particular area that you're not strong in, perhaps the 2 exam way is for you. But in general, I would advise you to take the single exam route. The CCNA articulates or marries up perfectly with the professional level certifications, which are the next level up. So that's CCNP. And there's a number of flavors of those as well, which we'll look at in a second. Then on top of that, there is the CCIE, the Cisco Certified Internetworking Expert, which is one of the creme de la creme of the IT networking industry certifications. You don't need to go through the CCNA, CCNP pathway to go to CCIE. You can go straight to CCIE, but you need a lot of experience. I would suggest you would need a minimum of 5 to 7 years of hands-on practical experience working with the devices that are on the blueprint and the versions of iOS that are on the blueprint every day of the week. So a lot of hands-on experience, very tough lab to pass, but a very high level, highly regarded certification. So if we just flick back, I'll just flick back to that certification screen. So that's our CCNA. Waiting. There we go. So we've got our associate level. So the CCNA in a number of different flavors, as we can see there, and then the CCNP. Some of these guys here, some of the CCNA certifications articulate directly into the professional level, and then the professional level will articulate into the expert level. Now, as I said, you don't have to do the professional level to go to CCIE. You can go straight to CCIE level should you want to do that. But the pathway is there to be able to build up your knowledge to get to that CCI level if you're starting from scratch or haven't got a lot of hands-on experience in the background. So the CCNA types, so there is a number of them, as we saw on the previous page. So cloud, collaboration, cyber ops, data center, industrial security, service provider, wireless, and of course, our favorite, the routing and switching, which is what this course content is going to talk about. Now, that's not to say that some of the course content is not going to be related to some of these other areas. Some of the principles that we talk about, such as the IP addressing, the OSI model, packet structures, and some of the basic technology that we talk about will, of course, be relevant to any of these particular CCNA streams. But within each of those streams, there then becomes specified specific areas of knowledge that you need to then look at, so which are beyond the realm of this particular online course. So the routing and switching exams for CCNA Accelerated and ICND 1 and 2, as you saw, I showed you those before on the webpage. There is also up on our Moodle site, there is this PDF, which gives you the exam breakdown, topic breakdown for the CCNA Accelerated exam. You can also get the PDFs related to the ICND 1 and 2 directly from Cisco's website as well. It's exactly the same content, it's just split up into 2 exams instead of 1, but otherwise it's exactly the same content. So we're going to traverse quite a lot of this particular content over the next 5 weeks. We're not going to go to the depth. I wouldn't expect that if you came into this course with absolutely no experience that you would be able to do these 5 weeks and then necessarily go and pass the CCNA exam. You will need to do, in most cases, you will need to do additional study and to get some hands-on experience, a little bit more hands-on experience on real devices in order to be able to do that, but it will take you a long way down the path. Some of these topics we will talk about specifically in the online sessions that we're in now. Some of it is covered in your readings, but between the two, you will get a coverage of the vast majority of the topics that are outlined in this PDF. So my advice is, if you are interested in moving forward and getting Cisco certification, starting off with a CCNA, have a look, spend a bit of time going through this PDF and just getting a feel and understanding for what the topics are and the sorts of things that you need to understand. Again, this is a very big picture, very high level, and we'll break down a lot of this stuff as we go along over the next 5 weeks. As I said, ICND 1 and 2, same topics, but spread across 2 exams, may be useful if you don't have sufficient experience to do the accelerated, but in general, I'd push you towards the accelerated exam. In terms of online labs, we always get lots of questions about online labs. There are many, many available online, mostly paid subscription type services, and they cater for various different flavours of the CCNA certifications or the CCNP certifications or even the CCIE certifications as well. Obviously, the further you get up the certification chain, the more expensive they are, the more time you will need to devote to those. They are very good options for people that don't have access to hands-on equipment in their own, whether that be in work or in their own lab at home. But there are many of them. There's a couple of suggestions there. The Learning Network store through Cisco, you can get them there. Boson also do some labs. There are many, many, many others. There's a couple of suggestions. They're certainly not endorsements. It's up to you to determine which one is best for you. The Cisco ones are obviously quite good because they're specifically tailored to meet the objectives that Cisco set in their certification. So they're as close to the real thing as you're going to get, but there are a number of other vendors that are also quite useful as well. And there are a number of vendors, many of them, that will provide you with actual remote console access to real physical devices rather than just having it in a virtual machine environment, if you like. Any or all of those are okay. It doesn't matter which one you pick, so long as you pick something that fits your budget, gives you decent performance and is appropriate for your particular time zone. In terms of other resources that I would recommend, there's a CCENT, CCNA Routing and Switch study group. Now, there are study groups for the other flavours of the CCNA as well. Obviously, we're focusing on routing and switching, so this is the one I'm going to recommend via that link there. There's also the Learning Network on-demand e-learning, which provides you with little vignettes, little videos, little hands-on exercises, some documentation, all sorts of things that will lead you down your certification path depending on your level of expertise. And then lastly, there's a Cisco Press website. There are many book vendors as well. There's Cybex, there's lots of them that will write and provide you with CCNA certification guides. They are all good. Some people have, for instance, a preference to use Cybex guides. Some people like to use Addison Wesley. I prefer to use a Cisco Press, but that's just me. I always think going straight to the horse's mouth is generally the best way to go, but you know, your mileage may vary depending on what experiences you've had with those. There are many other resources out there available as well. There are plenty of people that write blogs on this sort of subject matter. There are plenty of downloadable exam engines. There's lots of PDFs, lots and lots and lots of information about Cisco resources and Cisco certifications. Just keep in mind they are not always accurate, okay? I know people talk a lot about brain dumps. I discourage people to use those. First of all, they're illegal. And secondly, if you get caught using those and you can have your certification revoked, which is obviously not something we want. So in my opinion, they're not worth the risk. And sometimes they're just simply not accurate or based on really old exams and not really going to help you in your preparation. The best way to prepare is to go through certified study guides, get lots of hands-on experience, and ask lots of questions. The single probably best resource I can point you to, it's not necessarily certification-based, but it's the best resource going around, in my opinion, on Cisco stuff, and that's cisco.com, cco.cisco.com. Get yourself, sign up. The best thing you can do is sign up for a free Cisco CCO account. If you haven't got a vendor contract or an integrated contract, you won't get access to absolutely everything, but even a free account will give you access to an awful lot of different things, an awful lot of information that can help you understand big picture concepts about networking in general, but also specifics about Cisco hardware to allow you to then aggressively pursue the certifications in a positive and confident fashion. Yeah, so in terms of this course, The learning resources are, there's quite a few on the short course system webpage, so our Moodle site. So I'll just flick back to that briefly. So this is a Moodle site, which hopefully you will have all seen. Otherwise, you probably wouldn't have got the invite. There's a study guide here. So the study guide is this. Let's just open another tab here. And that gives you the basic idea of what you need to do for each week. Gives you a running sheet for the week. So the first thing I've said is register for a Cisco account, then enroll yourself in a packet tracer introduction course, which is run through a Cisco Net Academy. Launch the course, and it allows you to then download the packet tracer software, which you're going to need in order to be able to do the packet tracer activities that we offer in the resources, and we'll have a look at those in a second. So next thing is the webinar resources. So that's just your link to get to the webinar. There's a copy of the webinar slides there, which are what we're looking through now. So you'll be able to have a look at those. There's some readings, which for this week, there's lots of different readings in there. Now, you don't necessarily have to go through and read every single word in these readings. They are provided there to back up or to augment your knowledge in this case, particularly IP addressing. There's a lot of complexity around IP addressing, whether it's version 4 or version 6. If you haven't had a lot of experience with it, I suggest that's the first thing you really need to get up to speed with if you want to progress down the Cisco certification path. If you don't understand IP addressing, you will struggle. So that's the first thing, core skill that you need to do, is to get through that. And then there's a number of external links there that will give you access to resources that I would recommend you have a bit of a browse through this week, depending on what your background knowledge is. We then have some lab files. So that's these guys here. So there's 3 packet tracer labs this week. There will be packet tracer labs made available to you every week. And then at the end of the 5 weeks, there'll be some other general revision overview, which will look at a number of different technologies in each packet tracer lab. Now, these packet tracer labs are driven, so they're activities. They're not just labs that you open up and you can play with whatever you like. They are specific activities which will ask you to do specific tasks and help guide you through. So they're going to be more beneficial for those of you that haven't got huge amounts of Cisco experience. And by that I say probably less than 18 months to 2 years. They'll be really, really useful. If you've got 3+ or 5+ years of Cisco hands-on experience, then you'll probably find that this course may not provide you with as much as what you may be thinking. Okay, so but for those that are in that early phase of their Cisco certification career, you're going to get an awful lot out of it. Okay, that's not to say if you've got more experience you won't get something out of it, but it will be less useful because you've got the hands-on certification experience as it is. Hands-on Cisco experience, sorry. We then got our discussion points. There's a couple of questions each week. There will be a couple of discussion questions that you need to address in the forum. So I encourage you to do those and to share the knowledge around. There's already some posts in there, which is fantastic. Share that knowledge around, and I'll be popping in from time to time to make some comments, to ask some follow-up questions, to give you some prods in the relevant direction. And then lastly, each week we have a quiz based on the content around what we've discussed in the online meeting and also the other resources that are up on the website. You can do that as many times as you like. Doesn't matter, you can keep going, and it doesn't go towards your official result or certificate at the end of the online course. The only test that does that is the one that you do in week 6, and we'll talk about that one in particular when we get closer to that particular date. So please engage in the forum activities. They will help you without any doubt. So a text I recommend to people is that one there by Wendell Odom, who's an absolute guru in the networking space. He's done written a lot of books for Cisco Press, a lot of CCIE level text. He is I think from memory, a quadruple CCIE. So he's got routing and switch, voice security, and maybe service providers, the other one. And he's also done the Juniper equivalent, the JCIE as well. So a bit of a guru. His books are nice, are a really good read. They're well written, a bit light, a little bit entertaining, a little bit of humour, very good, and technically absolutely perfect. So I highly recommend that particular text for this particular CCNA routing and switching certification. Okay, some study tips, which I'm not going to go through in depth because we really need to kick on into the content, the main test of the content, but there's some tips here that I want you to have a look at in your own time and just think about them. Okay, they're really handy. These tips are not my own tips. I haven't come up with these. These have been come up by some guys from MIT, so the Massachusetts Institute of Technology, and they have come up with these tips as being very useful for anyone who is doing any sort of learning. Okay, so have a look at those, see how you can use them in your own learning. Okay, so is there any questions that anyone has on that particular part so far, and what we've spoken about that need to be answered?
There sure are, Matt. I'll just jump in now and cover a few things off. I've been getting quite a few questions about. First of all, again, all course material is available at the learn.itmasters.edu.au page. That's the course page or the Moodle page. Terms are interchangeable. From there, you'll be able to get your slides, your PDFs, you'll be able to download them, and you'll also be able to view tomorrow, in about 24 hours, an edited version of this video, just to make a nice cleaned up version. Another thing is, absolutely, people can register if they haven't already registered for this course. There's no cut-off date. You can keep on doing that. And then there's a few interesting questions that I might throw to you, Matt. One from an anonymous attendee who is interested to know whether this course will realistically prepare them as they continue to come in for the combined CCNA exam.
Yeah, okay, it is a good question. I sort of partly answered that just before, but it's not if you come in with absolutely no experience and you do the 5 weeks of this course, then I would not expect that you would necessarily be fully prepared for the CCNA exam. No. And the reason behind that is that there is a huge amount of content in the CCNA version 3, and it's simply not possible to cover all that content in sufficient depth to be able to guarantee you a pass for the exam in a 5-week period. And even so, it's impossible to guarantee that anyone will pass an exam the first go anyway, but it will take you a long way down the path to preparation for the exam.
Great. There's also another exam that we haven't, I'm not sure whether we've spoken about yet, sorry Matt. At the end of this course, we'll be having a multiple choice question for your certificates of completion. So that
yes.
will answer Aditya's question.
Okay, there's one. Programming in this course. There is programming in this course that is facilitated through the Packet Tracer Labs. So when you say programming, that's Cisco. That's programming Cisco switches and Cisco routers, Cisco devices.
And on that Packet Tracer, Stuart's asked, Packet Tracer Linux or Windows version better, or are they the same?
It doesn't matter. So the Linux version is obviously for Linux, Windows for Windows, but other than that, you can run the Packet Tracer activities on either one of those, no problem at all. I see there's a question about the CCNP exam without the CCNA. You can take a CCNP exam. You can take any of the Cisco exams without following the strict order of the certification, but they will not give you the certification certificate. So in other words, you can go and do a CCNP exam, yes, to show that you have the requisite knowledge, so it might be useful to show to employer to say, well, I've done this exam and passed it, but it won't count towards your Cisco certification until you get the CCNA exam, CCNA certification first. So you have to do them in the order and complete the different certification levels before you progress up. The only exception with that is a CCIE. You can go into that, just do the CCIE written exam and then do the lab exam, and if you pass, you're a CCIE. But in terms of CCNP, you must go through the CCNA to be officially certified. So Sean, sorry, yeah, I just seen Sean's asked about the CTO account. Yeah, you can select the guest account for creation, yep.
And we've had a couple of questions about brain dumps, wondering whether you could...
Oh, yeah, okay. So a brain dump is, and as I was saying before, they're illegal in terms of Cisco don't like them very much, but basically a brain dump is where someone goes into a certification exam, an official Cisco certification exam, and they somehow make notes or they memorize what's on the exam and then they write it down somewhere and they put it out on the public internet for everyone to look at. Cisco's done a lot of work at trying to subjugate that, so to prevent that from happening, and there are strong penalties in terms of certification revocations or being banned from doing Cisco exams if you are caught with any brain dump material.
Okay.
All right. Do you think we can move
on? Might just move on.
Okay.
Any others I'll try and get to by text, and hopefully the rest have already been answered. And we might just get you to download the webinar tomorrow if you're still a little bit confused.
All right, I'll continue on.
Thanks, Matt.
All right, so now into our content. So network fundamentals. So there's the topics that we are not necessarily going to touch on wholly in the webinar, but all the resources that you've been provided with through the week 1 Moodle site will provide you some discussion of, some knowledge of. Okay, so the first thing we need to talk about, these webinars, we're really going to drill down on the real fundamentals of what you need to know in order to help prepare you for the CCNA exam. So this first week is really about underpinning knowledge, big picture, general theories. And we start to get a little bit more specific as we go along. So the OSI reference model is the most popularly used model in networking, and I urge you not to underestimate its usefulness. I'll give you a little quick anecdote that many years ago when I first started my university education, I was sitting in a class and my lecturer was droning on and on about this wretched OSI reference model, and I thought, good God, when am I ever going to use that knowledge that he is sprouting about? How wrong was I? Once I got into the networking trade and I started to work with applications and service systems and desktops and firewalls and wireless access points and routers and switches, I found that I used the OSI reference model every single day of my working life. It provides you with a framework, a conceptualized understanding of how networking technology or any computing technology works from the level of cables and bits and bytes all the way up to where the user's sitting interacting with an application. Really, really important to get your head around this OSI model. The key concepts about it are there are 7 layers to the OSI model, and we'll have a look at what those are in a minute. A really good definition and a way to think about it is that it is a framework for all network communications, as I said, from the electrical specifications, so how bits and bytes are encoded onto cables or on wireless or on fiber optics or whatever media you're using, all the way through to the way in which the network communicates up through the OSI model to the end user application. Okay, so it's a comprehensive model, very simple in essence, but it encapsulates so much complexity, and it's a great starting point, particularly for understanding things from the ground up if you're new to things, or as a troubleshooting model as well. Absolutely outstanding. Now, the good thing about networking, if we're just talking about networking, if you have an understanding of the first 4 layers of the OSI model, you're doing well. Okay, they're the main ones you really need to know about. If you're starting to dabble in security or voice over IP or wireless, then yeah, sure, you need to know 5, 6, and 7. And even as a networker, you need to understand what 5, 6, and 7 are. But 1 to 4 is your bread and butter. That's where the nuts and bolts of your day-to-day work is going to be. So if we look at the OSI model, there it is there. Okay, so this model over here, and this is a comparison, this is one of the requirements of the CCNA exam, is that you have that comparison of OSI model and TCP model, TCP/IP model, DoD4 model. Terms are interchangeable. So it's sometimes called Department of Defense model, sometimes called the TCP/IP model. You could probably guess from what I just said about it being DoD model that it was initially a brainchild of the Department of Defense in the States. And they came up with this 4-layer model, which you think, great, 4-layer, nice and simple. OSI model. So OSI model, OSI, for those people that don't know, is a standards organisation, and we'll look at that a little bit more as we go along. But they're an organisation that comes up with different standards for different things. So, so this is their 7-layer model, starting at layer 1. So layer 1 to 7, going from bottom to top. So we have our physical data link. Now the data link is an interesting little layer because it's actually split into two. It's split into the MAC and LLC layer, and we'll talk about that more as we go out throughout the next 5 weeks. We have a network layer, a transport layer, session layer, presentation, application. Now the interesting about these things about these layers is they all have very specific tasks and things that they need to do, and each of those is written here at the bottom of each of the little buttons there, so you can have a look at those. The other interesting thing, and that's worthwhile understanding, is this column here refers to what information or data is called at each of these particular layers. So at the physical layer of the OSI model, information is called bits or bytes. At the data link layer, they're called frames. At the network layer, it's called packets. At the transport layer, it's segment. And then everything else above that, it's just called data. So when you hear someone's talking about a segment or a segment issue or segmentation, it's related to something, some sort of operation that happens at the transport layer. Okay, and we'll look at these in more depth as we go along each week. So this week's just introduction. Same thing when people are talking about packets, they're talking about network layer operations. Okay, so packet tracer is a application that looks at Cisco scenarios mainly from the network layer. Okay, there are other things that you can do with it, but mainly at the network layer. If someone's talking about a frame, so if you hear me talking about a frame, and you will as we progress, I'll talk about frames and packets and segments and all sorts of things, then frame refers to the data link layer. And then lastly, bits is a physical layer, so ones and zeros basically, that's it. So what's interesting to note is that in the DoD model or TCP model, internet aligns with network, and that sort of makes sense because internet is made up of IP addresses, so internet protocol addresses. That's what lives at network layer. Transport and transport are the same. But then we have network access. So in the DoD model, they just folded the physical and data link layers together and determined that that's just, that's a network access model. ISO came along and they split that in half and said, okay, I've now got data link and physical. So one deals with electrical signaling and cabling type and interface connectors and that sort of thing. Data link starts to talk more about media access control, logical link control, so actually being able to access that particular underlying media for the purpose of transmission of network data. And then application in the old TCP model has been split into application, presentation, and session. And again, we'll look at these in a little more depth as we go along. And there's some resources on your Moodle site that you can look at as well. This is a little graphic which just shows some of the different protocols and technologies that exist. And this is definitely not exhausting. There is absolutely heaps more than this. But for example, when we talk about applications, most people think about things like web browsers and Microsoft Word and Microsoft Outlook and those sorts of things. What we're talking about in a networking sense, so in an OSI sense, is really we're talking about the protocols that interface with those applications. So for instance, HTTP interfaces with a web browser to provide it with information that we request from a website. Okay, so that actually says FTP, that should be FTP, so file transfer protocol. So again, it's a protocol that allows you to transfer files from system to system, but it's not actually the application that does it itself. It's a protocol that an application uses. Same with Telnet, network time, DHCP, and PIN. TCP and UDP are the two transport layer that live under TCP/IP protocol, and we'll talk about those in a lot of detail over the next few weeks. And then network layer, we've got things like IP, ICMP, IGMP, and then data link and physical, we have our Ethernet standards, our token ring, our token bus, all those sort of things. Mainly Ethernet now, that's probably the most common, and you've got your WAN protocols that flip in there as well. and we'll look at them, I think, in week 4 or 5. Two key things I want you, well, actually 3 key things that I want you to get about the OSI model, other than remembering what each layer is, what it's called. What I want you to really get out of it is the way in which information flows up and down the stack. So we look at this particular diagram, we've got a subset of the OSI model here. So layers 1, 2, 3, 4, and 5. So physical, data link, network, transport, and session. And we've got our little references to bits, frame, packet, and segment and data. Now you'll see, if we're sitting in an application, so if we're sitting at a web browser and we type in www.cisco.com and we hit enter, there's a bucket load of things that happens in the background there before, on your local machine, before any information even goes out your interface card. And one of those is taking that request from your web browser and passing it down the OSI model stack from application down to physical, so that it can be turned from just basic raw code that you've put in www.cisco.com into bits, so a stream of ones and zeros that actually means something to a digital device. Because obviously computers don't care what we type in, all they care about is ones and zeros, ons and offs. So the 3 things that are really important to remember about the OSI model is, as information flows down the OSI model, so going from layer 7, 6, 5, 4, 3, 2, 1 downwards, it is what's called encapsulated. So we start off with data at layer 7, 6, and 5, comes out as data. When it gets to layer 4, layer 4, a layer 4 header is prepended to that particular piece of data. So it now becomes a segment. So that's what a segment is. A segment is upper layer data plus a layer 4 header. Then gets passed down to layer 3, where another header is layered. The packet header is layered on top. So it then becomes larger again. So a packet is a layer 3 header, layer 4 header, and data. Then gets transferred down to layer 2, where another header is added on. Now, if you don't understand what these headers are at the moment, don't worry about it. We will look at that as we go ahead. The key point you need to understand is that as information passes down the stack, it is encapsulated with a header for each layer. Each of the layers at layer 4, 3, and 2. Then when it gets to layer 1, it's basically encoded into ones and zeros. And off it goes, out the wire. At the other end, when it's received by a network station and it starts to progress back up the OSI model, those headers are stripped off, so that's the process of de-encapsulation, until lastly there's only the data left that is passed on to the web server port as the request for www.cisco.com. Okay? The other 2 things that you need to, so that's number 1. Number 2 is, any layer of the OSI model can only communicate directly with the layer directly above it or directly below it within its own stack. So example, layer 5 can only talk to layer 4 or layer 6 directly. It cannot talk directly to layer 3. Okay, so within the same machine, same device, same stack, you can only talk directly from layers that are right next to each other. In terms of having 2 devices talking to each other, there's also the concept of what's called peer communication. And that means that layer 4 on device 1 will talk to only layer 4 on device 2. So layer 4 on device 1 cannot talk to layer 3 or layer 5 or any other layer on device 2. So that's your concept of peer communication. That is between 2 devices. Within one device, layers can only talk to the layer above and below. Between 2 devices, they can only talk to the layer at the same level as they are. Okay, plus the process of encapsulation and de-encapsulation. They're the 3 key things you need to understand. Okay, so if that's not 100% clear for you, there's some resources on Moodle that you can have a look at, and also re-listen to this webinar again and just go through that process again until you get that right in your head if you don't already understand it. Okay, any questions on any of that? Just briefly, Just conscious of the fact that we've got a lot of stuff.
Yeah, absolutely. Matt, I've labelled some as questions that we'll answer live. So maybe if you scroll through and just get to those ones, take them, and then we'll move on after that.
Okay.
And
how many hours should you spend every week? Again, that's going to be dependent on your level of experience. So if you've got 0 to 1 year or maybe 18 months experience, I would expect that with this particular course, you're probably only going to need a couple of hours a week, 2 to 3 hours a week to feel relatively comfortable with the content. Packet tracer. Okay, so Craig's asked, can you learn with the packet tracer simulation materials, or do you need to obtain physical switches and routers? You can do a lot through packet tracer. There's a lot of sites that will provide you access to free packet tracer labs, but as always, being on the real thing is always better, in particular because the real thing is not limited. Some of the packet tracer labs are limited to the number of commands you can use and the number of features that are available. Clearly on a real iOS device, that's not the case. Packet tracer instructions on that. It's not difficult to use. If you basically install it, open it up, you'll need a Cisco account to log in. Or you don't have to. You can just go guest and it'll still work. And then just open the packet tracer lab, that you want to, whichever one you want to work on that you've downloaded from Moodle, and it will guide you through. But also, if you've enrolled in that course, my advice would be to go and have a look at that as well, and that will give you some really good hints and tips. Is this certificate valid in all countries? As a MOOC certificate, absolutely. You can put this on your resume if you like. Obviously, if you get the full Cisco certification, that's valid anywhere. Okay, Anonymous says, data gets encrypted at presentation layer. Why is there no difference in showing data as plain data, cipher data? They don't distinguish. It's not the OSI's the OSI model's job to distinguish between that. That's done with protocols that may run at that particular layer, as you correctly point out, but it's not specifically part of the model. Yeah, so DHCP is an application layer protocol, yes. Yes, there are processes that works with MAC addresses, obviously. The process does start with MAC addresses, but DHCP itself is still considered to be an application layer protocol. Good question.
Thanks, Matt. That's the last of those for now. Keep sending those questions in and we'll try and get to as many as we can, folks. There's a lot of you, but we'll keep going for now.
All right, keep going. All right, we have got a lot to get through. I've been a bit waffly. I'm sorry. All right, so infrastructure devices. Let's get through these pretty quickly because this is all pretty basic sort of material and there's lots of resources around for this. There are going to be 3 main types of network devices that we need to know about for comparison purposes. The main 2 you need to be across are switches, /bridges, or routers. We don't talk about hubs too much anymore. They're only included as a comparison. So hubs, as I said, they're legacy, rarely seen, useful for comparison only. The 2 things that are useful to know about, or 3 things really that are useful to know about them, they create single broadcast domains. So a broadcast domain is just an area in a network where if a device sends out a broadcast, everyone hears it. Okay, and the bigger a broadcast domain is, so the more devices there are, the more broadcast traffic is generated, the worse the network will perform. And that's because every time there's a broadcast, every device has to stop and listen to it to determine whether that traffic is relevant for it or not. So the bigger a broadcast domain, the more noise, generally the less performance. Okay, that's talking big picture. They also have a single collision domain. So a collision domain is an area of a network where all hosts sending at one time have the potential for their packets to collide. So if you think of a bus architecture, so a big long cable in the old days we used to have big long cables and everyone would just tap into that one particular cable. If everyone started transmitting at the same time, there was a real problem with packets colliding and becoming damaged. Okay, that's a collision domain. There are various mechanisms for single bus architectures to get around that, which we talk about a bit later on. But now with star topologies, different types of topologies, that alleviates those problems as well. And we'll look at that again shortly. The other thing to remember about hubs is that they're a layer 1 device. So all they do is regenerate signals. So as a packet comes in, if it's starting to die off or attenuate, it'll pump up the noise on it, redo the voltages and send it out again. So that's really all it does. Pretty simple, dumb device. Switches, on the other hand, or bridges, the term can often be used interchangeably. You won't hear me say bridge too much, but they can be used interchangeably, even though technically they're not exactly the same. Bridge was a forerunner to the switch, but they're near enough the same thing to just consider it so. These guys are ubiquitous, meaning they are everywhere. Everyone's got them. All enterprise networks have them. You'll see these all over the place. Lots of different vendors. Of course, we're talking about Cisco here. These guys have a single broadcast domain. Okay, so again, broadcast traffic's heard everywhere, but they have many collision domains. In fact, they have one collision domain for every port that they have. So if you have a 24-port switch, you have 24 collision domains. That's a primary difference between a hub and a switch at this base level. Okay, there's a lot of other differences, but at the basic level, that's the main difference. Lots of collision domains compared to no one collision domain. So if you have a 24-port hub, one collision domain, 24-port switch, 24. That therefore reduces the likelihood of packets colliding upon transmission, therefore reduces the requirement to resend packets, therefore improves the performance of your network. And switches work at layer 2 of the OSI model. So they work mainly on MAC addresses and logical link control, and we'll talk about that as we go along. Routers and layer 3 switches. So again, interchangeable terms. In many vendors now offer what they call layer 3 switches. So they're a switch with a routing capability. Routers, of course, are specialized for that particular function. And again, we'll look at these in more detail as we go along and what routing is and what switching is as we progress. Again, these are interchangeable terms. The key differences are, compared to the other two, there are many broadcast domains. So routers separate broadcasts, so they stop broadcasts from propagating everywhere. Also, every port on a router is also a collision domain as well, so it's double bang for buck. They're a layer 3 device in general if it's just a router, or a layer 2-3 device if it's a layer 3 switch. Okay, so they do a bit of both. Many of the Cisco switches are layer 3 compatible. Those ones there, bucket load more as well. And there are plenty of other vendors as well that offer devices that are layer 3 capable as well. So just briefly going into cabling, you don't really need to know a hell of a lot about this for the CCNA, but we just cover it briefly. So what does this even mean? As I said, you don't need detailed knowledge, just a basic understanding of the type of the cables and connectors available and how they interconnect to the devices and hosts. So understand basically that there's copper and fiber connectors in the main. We have crossover and straight through, which is related to the way in which the wires are configured inside the cables. That is less of an issue now. In the old days, you used to have to connect, say if you're connecting a router to a router or a switch to a switch, you had to use a specific crossover cable. You don't need to do that now because they have a feature which allows that to be automatically detected. So you can pretty much use any cable you like now. But it's there as legacy and there so that you understand it. And like for like, i.e. copper plugs to copper, fiber plugs to fiber. You can, of course, get converters that will go from copper to fiber, but in general, it's better if you can keep to one particular type, just because anytime you put a converter in place, you add extra latency, you add extra issues, extra potential areas of problems along the way. And the other important thing to remember is to match your hardware with the particular transceivers or ports, the cabling hardware that you're using that's relevant to your particular switch or router. Okay, speed is mostly auto-sense in enterprise space, but not always in a provider space. So depending on where you're working, you may need to hard code the speed. Typically, my recommendation is anyway to do that. If you're connecting switches to switches or routers to routers, then hard code the speed in the duplex settings. Why would you not? At least then you know exactly what you're getting. in a certainly to end host laptops and PCs and those sort of devices, auto is fine. If they mismatch for a little while, doesn't matter, reboot the computer and often that'll come back up. And the hardware is that reliable nowadays that this doesn't often happen anyway, unless there's bugs or errors, which of course can happen irrespective of what you're using. But just remember, if you mismatch the speed, you won't have an operating link. So if you try to, for example, connect a gigabit port or a port that's only gigabit to a port that's only 100 meg, then it won't work. Simple as that. Full duplex is always preferred. So duplex is just basically saying that it will transmit both ways at the same time. In simplex transmission, it'll only go one way at a time, or in simplex transmission, it'll only go one way. In half duplex transmission, it will go both ways, but only one at a time. Otherwise, packets will collide. And in full duplex, it can transmit and receive at the same time. So obviously, as you're able to do that, it will improve your speed throughput. If your duplex is mismatched, if half duplex one side, full duplex on the other, no good. You'll get terrible performance. You'll typically get late collisions at the full duplex end, and your performance will be abysmal. And the harder you try to push it, the more abysmal it will become. So there's lots of copper connectors. The standard ones are the RJ45 plugs now. There's not too many variants, but there are some. None of which you really need to know in depth for the purposes of either the exam at the end of this course or the Cisco certification exam. In terms of fiber connectors, there are many different types. There are many different wavelengths of fiber and light. They must be matched or you can end up with some very serious hardware damage. The most common issue with fiber is simply that the cable ends are reversed, so it simply doesn't transmit correctly. It doesn't work, won't talk to each other. And these become infinitely more complex with the chassis-based devices such as the 6500s, the 7600s, so on and so forth. Obviously talking Cisco-specific hardware there. CCNA mainly focuses on straight through or crossover cables and speed and duplex settings. So you may come across some questions in exam which will require you to differentiate between a straight and crossover, but not so many. Less of an issue now. So the role of the networking hardware, so switches and routers have fundamental traffic functions. As I said before, the switch creates collision domains, so one collision domain per switch port. So this limits the amount of collision traffic that occurs and therefore limits the amount of traffic that needs to be transmitted. Routers create broadcast domains, so one broadcast domain per physical or logical port. So on a router, as you will see as we go later on the course, if you're not already aware, you can have virtual interfaces or VLAN interfaces on a router. They are also considered the delineation point for a broadcast domain as well. So collision domains, we've sort of really covered that already, but it's basically a collection of devices that see each other's conversations irrespective of the source and destination address. And we've already spoken about hub and switch. So basically everyone sees everyone else's traffic and there is a potential for traffic to collide and therefore need to be retransmitted, thus creating an impact on performance. Broadcast domains, a collection of devices that see all broadcasts. So a broadcast domain is included within a collision domain. And broadcast domains are bad because the more broadcast traffic, the bigger the broadcast domain, the more hosts there are in a broadcast domain, the more broadcast traffic there is, the more hosts have to stop and listen to see if traffic is related to them. And if that's the case, then if it's not related to them, it's just a waste of processing time and therefore impacts the performance of your network. So broadcast domains are created either using VLANs or subnets, which we look at again later on the course. They do require a layer 3 functionality, VLANs and subnets, and what that basically means is you need a layer 3 device to communicate between VLANs and subnets. But again, we'll look at that later on in the course. So why do we use them? Speed up traffic, lessen the transmits, retransmissions, less lost packets, and if you do get errors, they must therefore be because of something else. So it's one less thing that you actually have to troubleshoot in terms of collision domains. In broadcast domains, it's really a no-brainer. It basically cuts down your broadcast traffic, which therefore, if you do nothing else, cutting down broadcast traffic will increase the performance of your network. So if there's any basic questions, quick questions on that I can answer, by all means point them out. Otherwise, I might just keep motoring on.
No, go ahead. Motor on. Yeah.
Okay.
We're running a bit over time, so folks, sorry about that.
So protocols and ports. Okay. CCNA mainly focuses on TCP/IP, so version 4 and version 6 both alike. Uses TCP and UDP at layer 4. The IP layer is a layer 3 or routed protocol, and we'll talk about what that means when we get to routing. TCP and UDP are layer 4 protocols, as we've seen in our discussion on OSI models. TCP provides a wide range of services and error correction mechanisms. So TCP is where if there are retransmissions or errors at that level, then error correction mechanisms are implemented there. UDP offers a lot less technically, which we'll see in a minute and in the diagrams, and it's faster in some respects, but there is less ability to recover from errors. So if we quickly look at the header, so the packet structure, transmission, so TCP, it's a connection-oriented protocol, which means it must establish a connection before it will transmit any useful data. The things I want to point out here are really just the source and destination ports. So that's related to, say, for instance, HTTP use port 80. And we'll look at these ports as we go. There's a diagram shortly which talks about some of those. And the rest of these, the important things that you need to know for the CCNA exam are related to the source and destination port. These other flags and other fields are useful and will come up in discussions as we progress through, but are not necessarily pertinent to the actual exam itself. Similarly with UDP, it's connectionless, which means it doesn't care whether there's a connection or not. It just starts sending traffic off and away it goes. You use this mainly where you don't need any guarantees about the delivery of the traffic. Again, source and destination port has to have that. There's a length and a checksum. Okay, so interestingly, so it's a lot quicker, a lot less overhead, away it goes. So it's in particular, one of the things I found quite confusing when I first ever learned about this is that, I wasn't first because voice came after, but UDP is very useful for voice and video because it doesn't have that overhead, just transmits really quickly and away it goes. So the introduction of that extra security or extra ability to recover from transmission issues is irrelevant with that. That takes more effort and more resources away from the actual voice stream or video stream, which is going to create more problems than it would if you transmit without that. So if we look at a quick example of ports, so we have Hannah and Jesse, two devices. So Hannah is just a client device. Jesse is a web server, has an ad application and wire application running on it. So we're using two different protocols. We're using both UDP and TCP, as we can see in the header here. Okay, so the ad data, ad applications using UDP, wire transfer TCP, web page TCP as well. Inside that UDP and TCP header, we have this information about which destination port we wish to go to. So in this case, the web port, as normal, standard, runs on port 80. The ad server is running on port 800 and the wire application is running on port 9876. So when that request is sent from Hannah to Jesse, Jesse knows to look at the protocol type. Is it UDP or TCP? If it's UDP, it then looks at the port number, says it's UDP port 800. Okay, I know my ad server is running on UDP port 100, so that packet must be for that particular application. I will forward that information onto that application. That's the basis, the nuts and bolts of how that operates. And this again is just broken down a little bit more detail, so we can see that the ad application will talk directly to the ad application. So the request on Hannah will talk directly to the application on Jesse, same with the wire application and the web browser as well. Some commonly used ports which are useful for you to know for the CCNA exam, all those there. Basically, if you don't know them, the idea is to memorize those babies because you'll come across them a lot in your working life. If you haven't already, there's a lot more but that are also available and also useful, but for the purposes of the CCNA exam, most of the questions, most of the information that you'll talk about will be concerning these particular ports and protocols. So as we were saying before, TCP is a connection-oriented protocol. So it needs to establish a connection before it'll transmit any meaningful data, and it does that through use of a three-way handshake. So in this case, the three-way handshake revolves around this process of sending sync packets and acknowledgement packets. So the full three-way handshake is web browser will send a sync packet to the web server. The web server will send back its own sync packet and an acknowledgement packet just saying, yes, I got the initial sync packet. And then the web browser will send back an acknowledgement packet to say, I got your sync packet, thank you very much for that. Now the connection basically becomes established, and we'll break this down a little more as we go in subsequent weeks. But the connection is then basically connected, and then we're able to commit to our transmission of regular data. There is also a termination process for a clean termination, and that just basically involves the use of finished packets and acknowledgement packets. So the acknowledgement is always there. There's always an acknowledgement to packets, and that's how we get around this process of providing that ability to error detection and correction. So if we receive a packet, or if we send a packet, and we don't get an acknowledgement for that packet, then we know, or we assume that it hasn't been received, and therefore we would retransmit it. So similarly, a termination is just basically the reverse of the three-way handshake, to bring it up. All right, we might keep going on questions, past questions for that particular section, because we've still got a bit to get through, and I'm mindful that we have run a little bit over time, but first week is always the most difficult one to get through. So let's crack on with the V4 addressing. V4 addressing is most valuable skill you can have as a network. I think back at the start I did mention that it's probably the key skill that you need to have as a CCNA candidate. It is tough to learn, but there are some tricks which we'll look at. There's lots of resources up on Moodle that you can have a look at, and there are a number of different mathematical tricks that you can use, and you may have come across different ones to the ones that I use. So there is no right or wrong trick. As long as you get the correct answer and you can do it consistently, then that's fine. Main thing with IP addressing, practice, practice, practice. And note that even after lots of practice, I still get it wrong as well. Lots of people get it wrong. So the basics. It is good to understand binary math. I'm serious about that. Good. I know it's only ones and zeros, but it's good to understand how to AND, how to OR, how to XOR, how to go through the basic binary transmissions. Let's do a quick primer. Okay, so 0 or 1 is basically off or on. We know that. Each of the columns within a binary number will represent powers of 2. So if we talk about a byte, which is 8 bits, 8 consecutive bits, the least significant column, so the one on the far right, is worth 1. And then each column is worth a power of 2 all the way up to 1024. So in this example, if we want to encode 10 decimal into binary, we would use no 1s, we'd use 1, 2, no 4s, and 1, 8. That would give you 10. So then 10 in decimal would then become 0, 1, 0, 1. Similarly, there's a representation in binary of 25 decimal. Okay, there's a number of IP addressing there's a IP addressing problem sheet and a number of resources on Moodle which will help you to consolidate that particular knowledge. So now we go back to IPv4. So IPv4, 32 bits in length, divided into 4 8-bit octets. When it's written in dotted decimal, it looks very familiar. So 192.168.0.1, so on and so forth. Okay, you'll all be very familiar with that. Each of those numbers is called an octet because if you turn it into binary, it's represented by 8 bits. So for example, 192 is represented in binary by 11000000. Okay, and again, there's a column values there. You can add those up, get to 192. 168 represented there, 0 and 1. Okay, so called octet because they're represented by 8 individual bits. There are a number of useful classes in IPv4 that you must know. particularly class A, B, and C. Class D, less so. Class E, probably not going to come across that too much, but class A, B, and C, definitely. This table is really important for you to understand or to have a look at if you don't know. Okay, so have a look at that table, go through it. The most important thing probably to understand is, from a binary perspective, this bit here. So all class A addresses will always start with a 0 in the most significant bit, always. Class B will always start with 10 in the two most significant bits. Class C will always be 110. So if you see a binary representation of the first octet of an IP address and it's marked as 110, you know automatically that it's a Class C address. If you see that the first two bits are 1 and 0, then you know it's a Class B address. And if the first bit is a 0, you know it's a Class A address. Simple as that. 127.0.0.0/8, so we'll talk about slash notation a little bit shortly, is a special case. That's basically a loopback address. So if you can't ping any other address, you should be able to ping 127 dot something. So 127.1.1.1.2.1.1.3.254.68.192. Doesn't matter what you put in there after the 127, you should be able to ping it. And that's because that's related to the IP stack on your actual device. If you can't ping 127 address, then your IP stack is not working correctly on your particular device. There's also the 169.254.0.0, so that's a /16. That's used for automatic private IP addressing, typically in Windows, but other devices as well. So the RFC 1918 addresses, so RFC 1918, so request for comments 1918, is a document which talks about private addressing. So those ranges there, and we'll talk more about these extensively as we go through the next 5 weeks, are the IP address ranges that are not routable on the public internet. So you should never see them out on the public internet. If you do, something dodgy is going on. There are 3 ranges of IP addresses, totally private, for use in private networks only. Anything outside of that range is publicly routable and is allocated by your ISP, or if not, and is there, and before that, allocated to them by the other regional internet authorities. So in our case in Australia, it's APNIC, Asia Pacific Network Information Centre. So IPv4 components, there are 2 components. There is a host ID and a network ID. The network ID is determined by the subnet mask, and this is where the binary math comes into it and things become a little bit hazy for people when they first start. So the host ID basically, if you think of it as being a specific street address, so this determines what house you're in, whereas the network ID is more analogous to the street you're in. So network ID is the network you're on, the host ID is the actual individual device on that host that you're in. So example 1, I've got 4 examples here, but I might just skip through a couple because we're certainly running short on time. So example 1, we have the IP address 192.168.200.33/24. Now what that slash notation basically means is that there are 24 bits in the subnet mask that are set to 1. That's what it basically boils down to. So they can either be 1s or 0s. So in this case, there's 24 bits that are set to 1. And we know that each octet is composed of 8 bits. Therefore, 3 octets, 3 times 8 is 24, must then be set to 1. So if we set all the bits in an octet to 1, the decimal value is 255 because we merely add up all the values of those pair of 2 columns as we go from left to right, and that yields a value 255. So in this case, the address, if we extrapolate that out into decimal notation, we see it's 192.168.200.33. The subnet mask is 255.255.255.0. So the question to you is, which part is the host ID and which part the network ID? So I will give you the answer anyway. So the way we do that is via binary math. And if you know how to do this, it's really easy. You don't need to do the binary math, but it's sometimes useful to go through that so that you can get a bit of an understanding of how this is done. You can, of course, use the subnet calculators, which allow you to cheat. but it's always good to have an understanding of it. So if we go through the binary math just quickly, this is a representation of the address and the subnet mask in binary. As I said, 255 is represented by all ones. And then basically all we do is we do a binary AND. So binary AND means if there's a 1 and there's a 1, then the result must be a 1. So if there's a 1 and a 1, the result must be 1. If there's a 1 and a 0, the result is 0. So basically all that means is everywhere, if you compare the address and a subnet mask, anywhere there's 2 1s, you yield a 1 in the final address. Anywhere where there's a 0, you put a 0 down the bottom. So basically what that means is in the subnet mask, anywhere where there are 1s, you'll notice that the first 3 octets of the top of the address is exactly the same as the bottom. And it's only the last octet where it's all zeros, which basically whitewashes anything that's in that last octet. So that basically reveals the network ID as being 192.168.200. So that's analogous to your street address, to your actual street. Thus, that leaves 33, so the last octet, as being the host ID. So you could effectively say that your device number 33 on the street 192.168.200, if you wanted to put it like that. So it's analogous to that switch and that street and house address. So the next part of that is if we have the network ID, which we do, we know what that is now, how many hosts and what addresses are valid for that particular network. So we know that the subnet in the mask, subnet in the example is /24, meaning that there are 8 bits left that we can use for host addresses. If we have 8 bits, we know that you can then have 256 usable addresses. Now, why is it 256? I'm glad you asked. The reason is because you can always use the 0 address, so you don't have any of the bits set to 1, and you can use the one that's all set to 1. So you have 255 non-zero numbers, plus you have the 0. So it's 256 variable addresses, but you can't use the first one because .0 represents the actual network address itself, and you can't use the last one because 255 represents a broadcast address for that particular network. So therefore, there are 254 valid host addresses. So anything between 1 and 254 is fine. Now, there are some exceptions to this when you start getting into supernets and subnets, but we'll look at that at another time. Basically, though, the format for how many hosts you can have on a particular network is 2 to the n minus 2, so where n is the number of host bits. So in our case, we had 8 host bits, so 2 to the 8 is 256 minus 2 gives you 254. So if we had to add 9 host bits, 2 to the 9 is 1024 minus 2 would give you 1022 valid addresses. Okay, example 2, I might just leave you guys to work through those in your own time. And if you have any questions on those, pop them up on the forums for discussion. Because they're quite lengthy, some of these ones. Suffice to say that the basic idea is you just need to practice, and there's some resources up on the Moodle, subnetting questions. And there's also a document, the 3Com document in particular, has everything you could ever want to know and a whole heap of stuff you don't want to know about subnetting that will give you lots of exposure to that. And it is a really important skill to have. If you've got no skill in it, my advice is to really work hard on it and get right up to speed with it. Very useful skill to have. Those of you that have been doing it for ages, it becomes second nature after a while.
Just on the forums, given you brought them up, Matt, with all of the questions that are coming in, we're not going to get to them all tonight. So feel free to start your own threads in those discussion forums and you can talk about them in there.
Oh, cool. Thanks, Guy. Okay, so we might I'll skip through those. Have a look at those examples in there and post any questions or any discussion points you want about those on the forums, and we'll generate discussion that way. Okay, I'll move on to IPv6. There's only a few more slides to go on this one. We're not going to do any. Sorry, I'm not going to go through any subnetting examples on this one because this would, I don't know about you guys, but it certainly make my head explode. The thing with IPv6, it is a whole different economy of scale. So IPv4 has 32 bits addressing space. IPv6 is 128 bits. That's enough addresses for 10 to the power of 15 hosts. I'll let you work out what that is exactly, but it's a lot. Basically designed to allow everything to have multiple addresses. So dishwashers, fridges, IP-enabled vehicles, etc., etc., etc. And we're seeing that happen already now, and there's plenty of examples of devices that use multiple addresses themselves. So IPv6 is certainly something that's gathering momentum, and I'm still not convinced it's well on the way, but it's getting there. So some of the advantages of IPv6, it's easier address management and delegation. Some may argue against that given the address space, but anyway, easier address management and delegation, that's why they sell it. Easy address auto configuration, and it'd want to be. You wouldn't want to be doing all of this statically. It's got IPsec embedded directly into the IPv6 protocol, which is really funky. Very good. Optimized, it's been written and optimized specifically for routing, and we'll see how that works when we actually get to our routing topic in a couple of weeks' time. And it has the DAD feature, the duplicate address detection feature, and again, we'll talk more about that as we go along. IPv6 notation, it's ugly. 128 bits expressed as 8 fields in 16-bit hex notation. Yes, hex. Most of you, I'm guessing, have probably seen this sort of notation before. It is very ugly if you don't work with it, but I guess it's no different to IPv4. When you probably first look at that, it's confusing, but at least you've only got 4 octets to remember. And I'm guessing anyone who's had a lot of experience with it, IPv4 becomes things that you just know. You just remember it. But it is ugly. There's no doubt about that. I'm not trying to hide that from you. There are some shortcuts. To make it look a little bit better, you are allowed to remove any leading zeros within an octet, and you can then completely omit successive groups of zeros, but you can only do that once. So if in this example, you can see, if I just scroll back here, we've deleted all the leading zeros. So where we've got 4 zeros in a field, they've now become 1 0. And then, so there, and there, and then here, we've taken out those 2 zeros and just got 2 full colons next to each other. You can only do that once, because obviously if you could do it more than once and you had, say, 3 lots of successive zeros, how do you know how many zeros are missing from there? You don't. So you can only do it once, which makes complete sense. But again, it still looks better than what it did beforehand. So similarly to IPv4, it's broken into network and host ID, and it's in this case 64 bits for each. So it has double the address space to what IPv4 had for each. So it's got double the address space for each of the network ID and host ID that IPv4 had in total. So it's hugely, hugely different. The host ID, so the network ID and host ID still serve the same purpose. So think street name, street number. The host ID is assigned by randomly generating a number, sometimes. It's also assigned by DHCP v6, so there's a specific version for IPv6, or it can also be generated by the EUI64 standard, which is really cool. So it uses the 48-bit MAC address of the connecting device and inserts the value FFFE into the middle of that particular MAC address. We'll see how that works in a minute. So that's basically doing it dynamically. So here's just a quick example of that. So we've got our MAC address here, split into 2 halves, and FFFE inserted in the middle there. That then becomes your IP address. Great, because we know that in theory, all MAC addresses should be unique. Should be. So IPv6 addresses come, or traffic should be, so it comes in 3 basic types, which is a little bit different. It's similar to IPv4 in that you've got your unicast, multicast, and broadcast. With IPv6, we have unicast, so it's a one-to-one mapping for a host. So one packet, host to host. We have multicast addressing, which is same as with IPv4, one to many. And then we have anycast traffic, which is one-to-many as well, but it will go to the nearest member of that one-to-many group. So it's one to nearest, if you think of it that way, one to nearest. And there are no broadcast addresses at all. So it's either multicast or one to nearest. Just a little, we'll sort of skip over this diagram a little bit because we'll explain it in the subsequent slides. But there's this concept of IPv6 scopes, which we don't go into a lot of detail about, but there's a linked local scope, a unique local, and a global scope, which we'll just have a look at now. So there's, related to those scopes, is that concept of a global unicast address. So global unicast addresses are addresses that are routable and reachable right across the internet. So they're not private, they are public routable addresses. They're addresses for widespread generic use, so allocated out to organisations, to ISPs, to whatever. Again, they're structured as a hierarchy to allow that concept of aggregation, so subnetting, supernetting, same sort of process as you do in IPv4. And they're identified by 3 high-level bits, which are set to 001 in binary, or as it says there in the slash notation for IP, 2000/3. So that's just a diagrammatic version of that. So we've got our 64 bits for our host, and then we've got our network ID 64 bits. We've got our 001 to indicate it's a global unicast address, and then we've got our various other parts of that to indicate site, LAN, so we can break it down per cust. If you're an ISP, you've got a big block of IPv6 addresses. You can use these constructs to break it down to geographic region, to customer, to whatever you want to do it with, individual LAN, however you want to do it. Again, we'll look at this more in depth once we start getting into the nuts and bolts of it. A local unicast address is an address that is analogous to a private IPv4 address. So in other words, it's only for use within the local LAN, doesn't go out across the internet. So it's used local communications, intersite VPNs where private addressing is used, so on and so forth. Not routable on the internet. If you want to route from those sort of addresses out on the internet or back in, you need to do IPv6. IPv6 NAT, sorry. And again, this is just a representation of that. So in IPv6 notation, FD00/7 is indicative of a local unicast address. So the linked local unicast addresses are basically they're mandatory addresses that are used only for communication between 2 IPv6 devices which exist on the same link. So mainly point-to-points, other opportunities to use it, but mainly point-to-point. Automatically assigned by devices as soon as IPv6 is enabled. They're not routable. Their scope is only link specific, link local specific, okay? So immediate link only, don't route anywhere. And they're identified by the first 10 bits being set to FE80. Thus, FE80/10. Okay, remaining 54 bits, you can do what you like with. Subnet, supernet, blah, 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 away you go. Interface ID, the last 64 bits. So multicast traffic in IPv6 have an 8-bit prefix. So if you see an IPv6 address that is FF00, you know that that's a multicast address. The second octet will define the lifetime and the scope of that multicast address. So in other words, how far it can go, how far it can propagate, and how long it will last for, how many hops. And that's basically a representation of multicast addressing there. So 128 bits, 8 bits at the start as prefix, 4 bits for the lifetime, 4 bits for the scope, and then 112 bits would designate the group, the actual multicast group that you wish to connect to. And there's that in summary formation. So node local, link local, so on and so forth. Just some examples of link local, site local, node local addresses and what they mean, how they apply to individual devices. Okay, auto config in IPv6, there are 2 main methods for this. There is the Slack method, stateless address auto config. You must have at least one IPv6 router to use this. The router will send out a RA, and for some reason off the top of my head, I can't remember for the life of me what that stands for. Router advertisement, thank you very much, Robert. Router advertisement permits on-link hosts to configure themselves as per that particular RFC. That's just a useful tidbit of information. Hosts use the IPv6 network prefix advertised by the router. Okay, so whatever the router is configured to use, that's what that particular host will use. And then the host will create their own host ID using that methodology of taking the MAC address, splitting it down the middle, and popping in FFFE into the middle, as we discussed previously. And the other way is DHCPv6. So pretty much similar in concept to DHCPv4, uses well-known multicast addresses, host sends out link local requests for addresses. So very similar process to DHCP version 4. Okay, and there's some resources up on Moodle site which will help you see the comparisons between those as well. All right, so we got through. So next week we're going to talk about some LAN switching technologies. So look about VLAN, spanning tree protocol in particular, heavily on that because there's a lot of that involved in the CCNA exam. A little bit around about Ethernet frames and some other funky layer 2 stuff as well, which are related to both VLANs and STP in some way. Okay, questions. Have we got any questions that you want me to answer, Guy, at this stage, or do you want just to hand over to Robert?
No, we've got millions of questions, of course. I might just get you to answer just one quick one. To what extent do you think for the rest of the course you'll be outlining specifically the differences between V1 and V3?
The main bulk of the course, so heavily, yes.
Great.
In short.
Okay,
yes.
that'll do. All of the rest of the questions, there's a bunch of great questions in there, folks, and we're sorry we can't get to them. We've just run too long over time. Chuck it in the forum, and everyone get involved and have that chat. Matt, would I be able to please get you to make Robert a host?
Can do.
Oh, it looks like I'm the host now.
Yes, you are.
All right, well, Robert, I'll make you a host, and then you'll be able to share your screen, and then you can go ahead with your presentation. Thanks for sticking around, folks. Have a chat with Robert.
Hi all, am I audible?
You are audible.
Okay, so Guy, are my slides in this presentation or are they separate?
They are separate.
Ooh, okay, I thought they were in here.
Okay, sorry about that.
No, all good. Let me try to find them.
So as I was saying at the start of the webinar, folks, Robert Hudson is the president of ITPA. He's here just to have a quick chat about what it is they do and why they do it.
Yeah, so I apologise all for the confusion. I thought the ITPA slides were loaded up in here. I will wing it. So
I'll find them in the meantime.
Oh, thanks, Guy. That'd be really appreciated. So for those of you who haven't heard of ITPA, we are the IT Professionals Association. We are a not-for-profit association based primarily in Australia who represent IT workers. We came from an organisation previously called SAGE AU, or the System Administrators Guild of Australia. We were primarily at that stage focused on system administration. We had been around since 1993, and last year we made a decision that we needed to rebrand the organisation and open up to IT professionals in general. So not just sysadmins, but developers to IT project managers to IT managers themselves. Basically, anybody who works in IT, we believe we can offer something to. In terms of the services we offer, to all our members, we have both non-financial and financial membership packages. We offer an advocacy and representation. So on issues that we believe are important to IT workers, we have commented to media, to governments, to industry, and basically advocated for our members' beliefs, understandings, and rights. On top of that, we have financial membership. Now, as a financial member, we provide additional services. There's a number of services that are mentioned on our website. One in particular I mentioned because it's quite topical to this course, is that all financial members receive a IPv6/48 portable network address allocation to use for as long as they're a financial member. So if you do want to do some practice with IPv6, you are more than welcome to use that for that purpose. One of the things that people ask about ITPA is, well, why do we need a representative body for IT workers in Australia? And as part of the answer to that, what we often talk about is another industry, which is the financial accountancy industry, which has two large representative bodies in Australia, which are called the CPA, or Chartered Practicing Accountants, and then the Chartered Accountants. Now, that industry is a much smaller industry. I think we worked out there's around 300,000 IT workers in Australia, and we have a industry participation in industry associations of somewhere around 5%. And that's between ourselves, the Australian Computer Society, Professions Australia have an IT arm, and a couple of other organisations like us. What has happened there is there's been a large number of decisions made by government, by industry, around things like the NBN, around internet filtering, that really it has not been possible for IT workers to get our point across. We're not a lobby group, but certainly we do represent our members and their interests, and we'll put forward our expertise to help with policy. When you contrast us with groups like CPA and Chartered Accountants, the accountancy industry in Australia has a over 100% participation rate in industry associations. So effectively every single accountant on average is a member of at least one industry association. And so CPA and Chartered Accountants are very often at the table when legislation is being discussed, or before legislation is being discussed, when it's been formulated, before it becomes public. So they have a lot of input into government policy, into industry policy and industry behaviour. And they get a seat at the table before any of this is public, because government and industry both know that if those industry associations decided they were going to speak out against a particular policy or a particular process or a particular operation, that they control a very large voting bloc and a very large purchasing bloc. And so what ITPA hopes to do is to be able to provide that level of representation, eventually, it's a long-term plan, to IT workers in Australia and internationally, to actually advocate for our understanding, our beliefs and our knowledge when governments form policy, when industry forms best practices. We are members of APNIC as an example. So we do participate in discussion on IP address allocation processes within the Asia Pacific region. We are founding members of a group called the Beyond 2020 Association, which is discussing what does online services and online processes look like beyond 2020, which is nominally the date the NBN is meant to be finished. And so we are starting to get more heavily involved in driving outcomes that meet not only our members' needs, but also the needs that our members know and understand that society requires and demands. So, ensuring that IT services are provisioned fairly to all, or as fairly to all as possible. And really, we'd love you to join up as at least an associate member. And in fact, by signing on for this course, you have become an associate member of ITPA, and we very much appreciate that. But we'd also like you to consider financial membership. Now, financial membership is $165 per year, which is less than the cost of a cup of coffee a week. And there's a number of services we provide. They're all listed on the website. To find out more about us, if you visit www.itpa.org, that's org.au, you will find a whole lot of information there. There's a question from Stuart: will ITPA help me get a job that I don't hate? One of the services we are working on at the moment is a job search and advertising process for members. There's a few other things we're looking at that are quite interesting in that space that may help you find that job you don't hate, or that employer that you're happy with. So that's one of the services we're looking at, we'd get to. Stuart, you spoke well. You get a read. That's really it from me. Differentiation between ITPA and the ACS. Look, we're a competitor as such to the ACS in some fashion. We're a complementary association in other fashions. There is position in the market for multiple parties, for multiple associations. Having multiple associations in the industry association business will drive those associations to better represent their members. The ACS are a completely valid membership organisation. If you believe they are the right membership organisation for you, absolutely select them. Being a member of one or more industry associations we believe is important. If you choose the ACS, you are more than welcome to do that. We fully support you becoming a member of at least one industry association. The ACS has a slightly different focus. Their focus tends, or has tended in the past, and I can't speak for them currently, to be more around management, academic introduction into IT. Certainly at one stage they had a requirement that you had a degree to be a full member of the ACS. We don't have that requirement. One of the other services we offer is ongoing education. This short course is part of that process. We also then track and recognise our members who are meeting continued professional development milestones. So that's one of the services we offer.
Okay, wonderful. So I couldn't find the slides, but what I will do...
what we can do, guys, put them up on the site.
Yeah, absolutely. Yeah, feel free to start a forum post about ITPA as well.
And certainly people can then ask more questions there. I know there's been a few questions that have flicked through that I'm more than happy to answer in the forums.
Beauty. All right, well, thank you very much for that, Robert. I'm sorry I didn't...
no, I'm sorry. I made the mistake of not having them ready.
Yeah, all I can do really is thank you very much, and thank you, Matt, for your presentation today. Looking forward to next week's. And thank you, all 950 odd of you who came in to have a listen to the webinar, and those of you listening to the recording at home at a later date. We'll be back next week. Other than that, thanks for sticking around, and have a good night.